Compressed air contamination in detail. There are 10 major compressed air contaminants. We will look at these contaminants in detail to understand the problems they can cause within a compressed air system. The amount of contamination in ambient air is concentrated when compressed to the relevant operating pressure. At 7 bar G operating pressure, there are 8 times the contaminants in 1 cubic metre of compressed air than in 1 cubic metre of ambient air. The higher the pressure, the higher the concentration. Contaminants 1, 2 and 3, water vapour, condensed liquid water and water aerosole. Atmospheric air contains water vapour, water in a gaseous form. Air's ability to hold water vapour is dependent upon its temperature and pressure. As temperature increases, more water vapour can be held by the air. As pressure increases, a smaller amount of water vapour can be held by the air. During compression, the air temperature increases, allowing it to easily retain any water vapour present in the ambient air. After compression, cooling the compressed air reduces its ability to retain water vapour, resulting in a proportion of the water vapour being condensed into liquid water. When the air enters the storage and distribution system, it is 100% saturated with water vapour. As the temperature decreases further in the air receiver, the 100% saturated air condenses more water vapour into liquid. This can cause corrosion to the storage and distribution system, damage to valves, cylinders, tools and production equipment, damage to products in direct contact with the air, increased microbiological contamination. Water in all 3 phases must be treated for the system to run safely and efficiently. Contaminant 4, atmospheric particulate. Ambient air typically contains between 140 to 150 million dirt particles per cubic metre. 80% of these particles are less than 2 micron in size. These will travel unrestricted into the compressed air system. Contaminant 5, microorganisms. Ambient air typically contains up to 100 million microorganisms per cubic metre. The warm, moist compressed air in a compressed air system is an ideal environment for further growth of microorganisms. Microorganisms in compressed air can cause product spoilage and potentially harm the customer. Untreated compressed air containing microorganisms exhausting from tools and machinery can lead to excessive workforce illness. Contaminants 6, 7 and 8, oil vapour, liquid oil and oil aerosole. Ambient air contains oil vapour, which is oil in a gaseous form. Typically, oil vapour concentrations can vary between 0.05 milligrams and 0.5 milligrams per cubic metre of air. An air compressor's aftercooler will condense some of this oil vapour into liquid oil and create oil aerosole. A liquid separator downstream of an aftercooler only reduces liquid oil and has no effect on oil vapour or oil aerosole. The remaining oil vapour, once in the compressed air system, will continue to cool and condense into liquid oil and create more oil aerosole. Oil vapour at the point of use can taint products and packaging with an oily odour. It can also make workers feel unwell. Oil lubricated compressors use oil in the compression stage for sealing, cooling and lubrication. They allow a small amount of lubricating oil to be carried over into the compressed air system as liquid, aerosole and vapour. Oil-free compressors don't use oil in the compression stage. However, almost all types available still use oil in a closed-loop system to lubricate bearings and gears. In addition to the oil entering the compressor from the ambient air, oil vapour and oil aerosole is released from the compressor sump's breather valve. This vapour and aerosole is drawn into the compressor's intake filter, increasing the amount of oil contamination travelling downstream. Oil aerosole and liquid oil mix with water in the system to form acidic condensate. Compressor condensate causes damage to the compressed air storage and distribution system, production equipment, products and packaging. Contaminants 9 and 10, rust and pipe scale. Warm, moist air causes corrosion of air receivers and piping. Over time, this rust and pipe scale slowly breaks away to cause damage or blockage in tools, valves and production equipment. It can also contaminate the final product or process. Purification technologies for contaminant removal. There are 4 sources of compressed air contamination: There are 10 contaminants that need reduction or removal for efficient operation of a compressed air system. It takes a combination of different technologies to reduce or remove the 10 contaminants. Here's what a typical compressed air system layout might look like, where a combination of various removal technologies are used to treat the compressed air for all 10 contaminants. Any condensate discharged by the system should be collected and removed in an environmentally friendly manner. Compressed air contamination in detail.